can we do versus what should we do? I think a lot of us have experiences with new technologies that feel like a little bit more like, oh, they were just doing this without thinking sort of why. Let's take a look, maybe spend a little time in the kitchen, the modern kitchen for a moment, to look at what experiences with new technologies often look like. And I want to take you back, get some slides up here too. Get some slides in a moment. I'm going to talk a little bit. Actually, you know that, you remember there was like an airport that had a new baggage system, and it was supposed to be awesome, but it took a long time. I was going to do this little thing about sort of like how we could sort of like make it feel like time was going a little bit faster than it is, but I was just buying time. My slides are here. Okay, here we go. Technology. All right, so I want to go back and take a look at a year ago. Some of you might recall the Juicero. And the Juicero was an internet-connected fruit and vegetable juicer, cost $700, and the big innovation for the Juicero was that it actually did not squeeze fruit or vegetables. It squeezed these processed juice packets, right? Which was awesome, except it turned out that you didn't actually need the machine to squeeze the juice packets. You could actually just do it with your hands, and it was the same result. Either way, you were just drinking the stuff out of the packet, right? So you might say, I don't know if I spent my $700 in the right way. Maybe we didn't need this internet-connected fancy juicer. In fairness, you could also use the device to read the barcode on the packet to tell, for example, if the expiration date had come and gone, that's not bad. On the back of the packet, though, they actually had printed the expiration date. So, I don't know. Maybe it wasn't super useful. What we wound up with here is an expensive kitchen gadget that solves no problems and does no work. This is actually not a new thing. This is actually part of a long history of abuses in designer juicers. This juicer, designed by Philippe Starck, just makes a mess if you try to juice lemons with it. But it's okay. Starck says he actually never designed it to juice lemons. He designed it to start conversations. That's some bullshit right there, right? This is the ego of the designer, or often of the technologist. This is self-serving when I think that our job is to serve others. So this is the enthusiasm for the making of the thing rather than the service that the thing might do. It's a trap that we often fall into, where we fall in love with our material, but not with how it actually should be used. The modern kitchen is full of stuff like this. Friends, you've all been waiting for it. Your Wi-Fi-enabled kettle, right? So a Brit named Mark Rittman owns one of these things, and he set about trying to make a cup of tea, but the kettle encountered a little bit of network trouble. Turns out it couldn't connect, and the kettle asked to be recalibrated. So now, 3 hours later, the thing had sabotaged his Wi-Fi router and disappeared into some nether region of his network. Mark is undefeated. He's port scanning his network to try to find the thing. And finally, 10 hours later, he got the kettle back online and working, but then his smart lights cut out, right? Because they needed a firmware upgrade. The internet was not exactly sympathetic to his plight, right? Sorry for the language. I'm just reporting the facts here, just reporting the facts. So Fast Company used these words to review yet another connected kitchen device, and it doesn't even matter which one, really, because you could substitute this language for all kinds of new technology products that we use, right? It's sort of this overreaching that we feel of automated yet distracting, boastful yet mediocre, confident yet wrong. I work at the intersection of technology and hubris, right? This is the way that it often feels as consumers of these things. And these are signals that we don't yet understand the grain of a technology, how it wants to be used. I think that's a question that we need to approach any new design material with. Or even better, how can we use this technology in a way that adds meaning for our customers? Or even better, that amplifies their human potential? And these questions are especially important when we turn to new chapters of technology, and I believe that's one of those times. We're working in digital design at what I consider to be a really exciting moment with the arrival of a new design material called machine learning. As Alexis mentioned, I run a design studio in New York City called Big Medium, and we focus on design for what's next, helping companies engage with new technologies in meaningful ways that solve real problems. And for the last decade, a lot of that has really focused on design for mobile, pushing the frontiers of what mobile is capable of. But in the last couple of years, a lot of that focus has started to shift to what can we do with data and machine learning and artificial intelligence. I think that if digital products have been defined in the last decade by the arrival of mobile, that machine learning is already set to define the next. And it's like an urgent moment for designers to be involved with this. So machine learning is a design material, just like pen and paper are a design material, or HTML and CSS are design materials, or prose, or dense data are design materials. And like any design material, it's important to understand its texture. Not only how it can be used, but how it wants to be used. And I think these are the questions that we should ask when we engage with a new design material. And I argue these are great questions to ask for any new technology, any new technique. And I want to explore these and how they look with machine learning, all right? So what can it do? What is its grain? How does it want to be used? What are its strengths and weaknesses? And how does it change us? That's what we're going to talk about here. Sound okay? You guys doing all right? You look great. You look terrific. All right, so let's start here with this first question. What can it do? Or put another way, why should you work with machine learning as a designer especially? You're not a technologist, you're not a data scientist. The opportunity as you're designing products is to ask, what if we could detect patterns in anything and act on them? Machine learning already drives so many of the digital products that all of us use every day, for better or worse, and usually both. Algorithms determine the news that we see, the movies that are recommended to us by Netflix, the products that are surfaced by Amazon, the way we drive home from work. And all of these things are due to this pattern matching power of machine learning that are surfacing generally useful insights. So what does this mean for you in your everyday practice? There are broadly kind of 5 applications of machine learning that you can use. I'm going to walk through just a few of these, just as very quick examples. I'm going to start with recommendation. Slack launched a feature about a year ago for big teams that helps you find people who talk about certain topics. So this is machine learning that helps you find experts in your organization. If you need an expert in the hiring process, Isabella is your go-to, right? So this is just recommendation, very familiar notion. It's a ranked list of documents that match a specific context or concept. So it's not, keyword search. It's actually sort of saying, here's a concept, a new kind of way to order information, and these people are tied to that concept. So that's closely related both to classification, which I'll discuss in a bit, but also to prediction. So let's take a look at that. So predictive keyboards are another example of just everyday machine learning. The statistically most likely next word showing up above the keyboard. So it's just a simple intervention to speed the error-prone task of touchscreen typing. And that's prediction, right? It's based on historical data. Here are the things most likely to happen next. Classification is sort of another similar thing. Google Forms, which is likely familiar to many of you, the survey building tool that Google offers. When you add your questions, you choose the format of the answer that you want. The default is multiple choice, radio buttons. But there are a lot of options here, and they've made it as simple as they could, but it still takes some time and thought to parse all of those. But look what happens when you start typing the question text and how that changes the answer format. So how satisfied are you maps to a linear scale. They added a little machine learning to the mix to look at your question and then classify it to a specific answer type. So which of the following apply maps to checkboxes. It's just this convenient bit of intelligence to make the process easier. So classification, in other words, is just human-generated categories where the machines map content or data into those categories. And friends, you heard it here first. You just sprinkle a little machine learning on it. Right? These are almost incredibly mundane examples, right? So if you came here and you're like, well, I'm going to learn how to build my sentient robot butler, that's not the immediate application for this stuff, and probably not the long-term application of what we're going to be working with for a while. The idea here is that we need to get as comfortable designing for the algorithm as we've become designing for the small screen, or just like it's second nature to add interaction to a web page using JavaScript, now we can add intelligence to a page by sprinkling a little machine learning on it, right? It's this enhancement that's becoming part of the everyday for a few select companies, and very shortly for all of us. So one of the big messages and takeaways that I want you to have here is that we have this opportunity to bring this in very just sort of everyday ways to our work. But this also means that we can bring a little humility to our fancy new technology. It doesn't have to be a big deal. In many cases right now, machine learning is best deployed for these small interventions that solve critical tasks in any given activity. But there are also some bigger opportunities. So I want to take a look at what happens if you point these tools and applications of machine learning at the kind of work that we all do here in this room. You probably recall Quick Draw. This made a splash a couple of years ago, a Google experiment to identify sketches and doodles. And it's basically Pictionary, but the machine is playing. So it prompts you to draw, for example, a mountain, pretty easy one. You sort of do that. It's like, wait, I know, it's a mountain, it says, right? So then it's like, great, draw a calculator, and it's guessing here at the bottom. I see a square, a triangle, an elbow, a dishwasher, a calculator. Right? It's getting it pretty good, pretty fast. All right, hamburger. I see a shoe, a hot dog, hot tub, bread. It's a hamburger. Almost had hot tub. Flip-flops. I see a nose, potato, peanut, flip-flops. That is so not a flip-flop. Not even close to a flip-flop, right? But it got it like immediately. So you can look at what else it was thinking. It was like great here. It's like flip-flops, great. Could have been a potato, maybe some bread. Not things that you usually think of as being confused with flip-flops. And yet when you look at what other people drew, these aren't exactly very flip-floppy either. These are not accurate representations of flip-flops, but the machines have sort of understood these as symbols for flip-flops, right, that we all can recognize too. So it's now this association of symbols with this vocabulary that we have. And this is, of course, this kind of work that we do all the time for digital designers creating interfaces, these familiar set of symbols that represent something that will be transformed into an interface on the screen. So what if machines could learn what those mean? There's a growing number of services experimenting with exactly that. One of them is Wizard, Uizard.io. I don't know. You decide. The idea is that you point your camera at this sketch, for example, and here I've just sort of made a sketch of just a very sort of simple inbox screen. You take a picture of it, it uploads it to the server, and then within about 20 or 30 seconds, you can sort of see that it's actually created a UI. Here on the left is my sketch, and on the right, it's actually sort of turned it into a UI. It's not just a visual, it's actually got sort of a sketch version. It's got an HTML and CSS for a very sort of fluid layout that actually works okay. So if we go and we look at what the sketch file is that it's generated, you can see it's just like a sketch file you might put together. It's all editable. You can go in and sort of edit this text. All of the individual elements are things that can be edited, changed, moved around. We've got these little checkbox controls, for example, you can get in there, but all that whole row is treated as a group. If you drill into one of these text fields, you actually see, oh, wait a second, this is a sketch library. These are all symbols. And what's happened is the system has associated these doodle sketches with a symbol in the library. Now, this is all sort of brittle. It has a limited set of patterns that it understands. And it's probably true that these aren't your styles. Or for the page that it generates, it might not be your company's code conventions. So while this is a nice start, it's also not necessarily something that I can use for my projects. But what if the system was tuned specifically to your brand and your site and your code style? What if you helped the machines map the patterns and symbols to the standard vocabulary that you use in design? When we do that for humans, we call that a design system. Right? Design systems establish standard patterns and a common vocabulary around them. And if you've established that, you can share that language with the machines too. Add to it the symbols and notation that you already use. But speaking of vocabulary, maybe you don't even need the sketch in the first place. Maybe it's just, hey, Alexa, give me a page with these elements. And all of a sudden, you've got a rough working prototype. And some of you might be saying, well, wait a second, that's my job. It's like, I'm the one who does those sketches. Or maybe change them into a working prototype. But it's not. That's not your job. That's the clerical part of your job. That's the transcription, dutifully translating a sketch to a comp and into markup. That's not where the real thinking happens, especially if how to do that individual element is already solved. The whole idea of a design system is encoding those solved problems. So only now we can share those solved problems with the machines so that we can solve new ones. So just step back, you sort of think about what are the tedious jobs, the clerical parts of our work, perhaps, that people find painful, the jobs that are time-consuming and repetitive and detail-oriented and error-prone and joyless. Nobody wakes up in the morning to be like, I can't wait to do more joyless tasks, right? But you know what? The machines love those things. They're great at them. Let's let the machines do those things so we can focus on what we do best. Let people do what they do best, and let the machines do what they do best. They are almost never the same things. So how might we amplify our humanity by supporting our activities in ways that are uniquely possible through machine learning? You know, when we ask what machine learning can do, this should be the designer's answer and goal. The effort should be to focus attention and human judgment, not to replace it. Not to have those prescriptive systems that Alexis mentioned, where we have no agency, where we just have to take the algorithm's news feed as it is. How can it instead help us draw attention to the things that we should be looking for? Clear away the noise and help signal where we can do our most interesting and creative work. You know, our industry has spent a lot of time and effort making the machines smarter. Let's instead put a premium on how we might augment human capability. Let's start with that human need and understand how the machines can help. I want to turn a little bit then to sort of like how might we do that and how do we work with this new design material in a way that actually does provide some meaning? What are the unique qualities of this material that gives us cues for how we should work with it? What are its strengths and its weaknesses? There are a lot, but today I just want to share three. And the first is that, friends, the machines are weird. They've come up with some strange freaking ideas. So they study the world, they sift through enormous volumes of evidence and data, and they come to, shall we say, some surprising conclusions. So, for example, it takes a human being about 14,000 brain hours to learn to run. And it turns out that an AI can figure out how to run in less than half as many CPU hours, but the results look like this. Using the arms for forward momentum, kind of little consideration of the physics of motion, or here the physics of rotator cuffs maybe, right? But then again, we also come up with pretty strange approaches to locomotion ourselves. Some of you may recall the prancercise craze of 2013. Oh yes. So when people are so difficult to understand, so often unpredictable and eccentric, how can we expect the machines always to make sense of what's happening? Because, you know, if the machines are weird, it's in part because we're weird, right? We may not totally understand ever what we look like to the machines from the other side. We communicate and behave in ways that are not always predictable or that themselves are somewhat fanciful, right? So what do the machines make of us as creators or artists? This Renoir painting is in the collection of the Barnes Foundation in Philadelphia. And when curators there ran it through a computer vision algorithm for identification, the robots confidently identified this painting as a boy holding a teddy bear. And you might look at this and be like, yeah, that doesn't seem so good, right? This probably is going to maybe be a problem with automatically tagging and describing the collection. It turns out that the curators didn't actually see this as a failure. When they asked a neural network to find cherubs in their collection, it found things that were definitely not cherubs, but also were kind of cherub-like. And the curators began to make some interesting connections. There was some creative and productive friction in the way that the machines grouped and clustered the art collection. Shelley Bernstein led this machine learning effort, and she described these connections as magic. that these unexpected results had generated new insights. So I think one big thing to sort of think about is, what are the opportunities from this strange weirdness that the machines bring to this to draw connections and clusters and groups and trends that otherwise would remain invisible to us? The patterns and connections that they make surface themes that we don't otherwise see. So we're looking at connections here between artworks, but that also means you can use it to identify clusters of products or customers or people by behaviors or associations that, again, might not be immediately apparent or obvious to us. So just the value of the unexpected there. Let's sort of pivot and talk about unexpected visitors. BJ May has one of those fancy Nest doorbells with a connected camera, and he set it up to lock when it doesn't recognize someone. But one day it locked on him, and so we went to investigate sort of what happened. He looked back in the app's history and saw that the system had spotted a new person and said, I don't think we should let this guy in. Lock the door. This guy seems angry. So the machines perceive and interpret the world very differently than we do, and weirdness and unpredictability and mistakes are just essential to this design material, which means that the more that I work with machine-generated results and machine-generated content, and especially machine-generated interaction, where the machines themselves are in charge of this stuff, the more that I realize I'm not in control of that experience as a designer, and that's new. We're used to designing a fixed path through information and interactions that we control. We're used to designing for success and for the happy path. And now we have to anticipate unknown content with a fuzzy range of results. This is always our job, but especially now, I think that our challenge is to set expectations and channel behavior in a way that matches up to the system's ability. The Siris and the Alexas and the Google Assistants of the world, the expectation they set is, ask me anything. And of course, as incredibly capable as all those systems are, they can't answer everything. And so this misset expectation means that they're constantly disappointing us because it's an expectation they can't fulfill. And that's a design problem. It's a hard one. But we run into these miscalibrated expectations all the time. PicDeskBot is a little Twitter bot that basically just takes an image from the internet, submits it to Microsoft's image recognition service, and then just faithfully returns its description. You can see it's pretty good sometimes. Here's a complex image and a pretty sophisticated description. It's kind of charming and weird when it gets confused. I don't know if you guys are familiar with Samsung's latest. These phones just keep getting bigger. The problem here is not just that it's not accurate, that's a data science problem, but it's the undeserved confidence of the statement. That's a problem of presentation, of design. Research on machine-generated descriptions finds that most people prefer results that are vague to those that are flat out wrong. So when the algorithm's confidence is low about an answer, and I'll talk about that in a moment, it's better to dial down the specificity to improve accuracy. So this is actually better, if not exactly super descriptive. But what if we split the difference and offer some of the low confidence possibilities in the way that a human being might explain it? It's a person holding an object that's maybe a cell phone, right? It's like that actually changes the manner of the thing and also sort of signals us to engage our human judgment on what's happening here. It's actually sort of more representative of how the machines see the world, a bunch of competing possibilities, competing signals. So in other words, one of the challenges that we have is to actually match that manner and language to the system's actual ability. The presentation of machine-generated results is as important as the underlying algorithm. And the thing that enables this flexibility is that algorithms faithfully report their confidence in the answer. And that's because, this is the second thing I want to mention, machine learning is probabilistic. Machines see the world in shades of gray. They do not deliver answers. They deliver statistic probabilities based on what's come before. It's all probabilities. So its algorithms are explicit about their confidence in their predictions. And you can investigate that yourself, and I encourage you to, by using one of the many, many easy-to-use machine learning services out there, which you can plug right into your own applications or prototypes with the skills you already have. Microsoft's cognitive services is one example. Amazon, Google, and IBM all have similar offerings, basically free to experiment. You get access to machine learning superpowers around vision, speech, language, and a lot more. So just to give this a spin, I am self-absorbed enough that I'm going to take a picture of myself and give it to the system and see what it returns. And you get this structured data in return. These are your working ingredients as a designer. And to dig into it, you can see it actually does pretty well, right? So it's like, oh, a man looking at the camera, confidence of about 89%, that's not bad. It's telling you how confident it is. I'm not totally sure about some of these tags. I don't know, right? And I mean, also, come on! It's just, I'm working on it. Working on it. But if you look at the percentages, you get a sense of sort of the confidence here. So we've got person, 99.966%, right? It's doing pretty good. It's a man, 97.7%. Down at the bottom, I'm happy to say it's only 28% confidence that I'm older. Then what? I'm not sure. But the tags at the top also organized in descending order of confidence. So it's person, man, indoor at the top. I'm happy to say elephant is the last one there. So you can see that actually we're getting a lot of nuance in these results that we can use to present a more nuanced description than simply saying, this is an old elephant, right? Because it's like we can actually see that there's very low confidence around that. Now look, as much as I admit that I really do care whether I look like an ancient elephant, other people have much sort of higher stakes at work here. We're starting to see police using face recognition algorithms or pattern matching for predictive policing to pluck suspects out of the wild, and that's pretty serious. Are the machines up to that? Well, the ACLU ran photos of Congress against a data set of 25,000 mugshots and got 28 matches. So Amazon has proven through science that Congress is a bunch of crooks. It's basically the takeaway. But if we look under the hood here, ACLU left the setting to the default, which declares a match when there's 80% or better confidence. And Amazon, not exactly happy about this particular coverage, countered and said, hey, hang on a second. We tell police departments to use at least 95% confidence. It's a probabilistic tool. You have to choose an appropriate level of probability to the seriousness of the problem. But in a way, that makes the ACLU's point. The machines require careful tending. And for those of us who are close to the machines, we have to understand how confident and accurate they are. But we also need to make that transparent to the people on the other end of it, the civilians, the customers who get those results from us, because this has real impact and can have very hurtful impact. So all to say, a lot of times we use these systems to rush to an answer, but it turns out that I think I know is better than a wrong answer. Maybe an older man? Could be an elephant? How do you turn it into a suggestion or a signal instead of flatly saying, this is an older elephant, right? So present information as signals or suggestions, not facts. That's a sort of a big takeaway. The manner with which we present information is astoundingly important. And the way we think about those signals is important too, because they're always relative to a baseline. This is the third and last thing I want to talk about here with designing for the grain of these things. The whole idea of machine learning is to identify and categorize the typical, the normal. It can then predict or recommend the next normal thing, or identify things that are outside the norm, fraud or crime or disease. But what is normal? And according to whom? Right? When you ask Microsoft's image recognition service to identify this picture of David Bowie, it sees a 29-year-old woman. And so at a moment when our culture is in the thick of a shifting understanding of gender and sexuality, how are the machines possibly expected to keep up? Normal is a mutable idea, and it's rarely a perfect one. So a system's output is only as good as its input. What if the prevailing notion of normal is actually garbage? What if our machines learn from us our own bad or dubious choices? What if they absorb and reinforce existing inequalities or leave out entire categories of people? Amazon discovered that the system it used to filter and recommend people for jobs was biased against women. The historical data, the characteristics it optimized for, favored men unintentionally, but nevertheless. And that's bad news. The less bad news is that when they discovered this, they pulled it, that the machines had revealed a systemic problem even as it sought to reinforce it. So surfacing bias might actually be useful. The machines surface this bias naively, in a matter-of-fact way, without obfuscation. They make obvious what's always lurked beneath, and it reveals the problems that we have to solve or address, maybe in our mathematical models, or perhaps in ways that culture operates, or the limitations of our own narrow professional circles. So when bias is revealed, we can act on it. It gives us signals for necessary change. So we may not be able to eliminate bias from our data, but we can at least surface that bias as a call to action. And so that's just what I want to close with here, is what intentions will we bring to this technology? And how willing are we to consider that things will go wrong? Because it does all the time. And that the technology will have unintended consequences. And friends, I'll just say that if we don't decide, the technology will for us. I think the thing that we can all agree on is that the future should not be self-driving. That is up to us in this room. Because if it determines it, this is what it's going to happen. The technology running the show, the tea kettle holding a family hostage while it's working hard to restore the network just to normalize the life and keep the kettle happy. So let's be explicit about the vision that we want instead, not just how we want tech to function, but what we want to enable. Instead of humans working for the machines can amplify our potential by doing our joyless work for us and delivering new insight from it. We don't have to be passive recipients of an algorithmic news feed. There are new design patterns to be invented. So instead of hijacking our agency, the machines can augment our judgment so we can be more creative, more thoughtful, more compassionate. And that's up to us, the people in this room. We're designing this future. We're deciding what this is for. So as we've seen, things can go wrong in ways large and small, but I'm optimistic. And I choose to be excited. This new design material is ready to use, and some of the services we've already seen available to you with the skills that you already have. Put those tools to work in small interventions or in large, audacious projects. You have the chance to do that, to start working with it today, and to start to actually make something amazing and meaningful. So please go do that. If you're interested in learning more, I just want to point you to a few resources. Mindfultechnology.com is a company and a movement about creating products that focus attention instead of distract it. UvetAgenda.org is the output of a retreat that I was part of with a bunch of designers, researchers, humanists, science fiction writers about the questions we need to ask about machine learning and artificial intelligence. And my own site, bigmedium.com, where you can find more on this topic. Only one thing really is left to be said.
So let's stop talking and do some walking.
Thank you very much.
Thank you, Josh. So I just wanted to ask you a couple of questions before I let you get off the stage.
Yeah.
But as we think about the kind of bias that's implicit in a lot of machine learning, how much do you think that our role as designers is to use it as a design material with an awareness of those biases, the way it reifies our existing realities or its training data?
Yeah.
And how much do you think it's our responsibility as designers to engage kind of at the meta level about how those systems are trained and designed?
Yeah, I think both is true. So I was really sort of focusing on the first here of like how do we deal with biased data in the products that we make. But in a sense, gathering data is UX research at an unprecedented scale. And sort of defining what is the question, how do we answer that question, who holds the data for that question, and are we talking to all of the audiences that are needed? These are all questions that any good design team will ask. It's just now we have sort of a different scale and a different set of partners, the data scientists and the other folks who are gathering this. So I think that actually it's like the biggest part of design's role in this is figuring out what are the problems that are worth solving that we should point the machine learning at. And I think being participants in that process of being like, so what does that mean? Who do we need to ask and what's the data that answers it is really an important piece that we have not been part of, that we've sort of ceded that to the data scientists and the algorithm engineers who have shown us what's possible, but now I think we need to bring sort of a design sensitivity to how to deploy this in a way so that it's not just, as you said, what can be done, but what should be done.
Yes, great. Thank you so much. Thank you, Josh.
Thanks, everyone.